integral versus as a net change. So the position of a function can be found by taking the what of the velocity? The integral. The position, right? Slope would mean I'm going to acceleration, right? Oh. Okay, the change in position is a displacement. Okay, so here's some terminology that you really have to know the difference between displacement and actual distance. So displacement is the difference between the starting point and the ending point. So to kind of distinguish between the difference between distance and displacement, if I say 2 steps forward, 1 step back, what's the total distance traveled? Does everybody say it's 3 steps? But the total displacement is 1 step forward. Do you understand the difference now? Yes? So integrals will give you the total change in displacement. Does everybody understand why that makes sense? Because it's subtracting the part that's underneath the x-axis, right? So to find the total distance, we use the integral from a to b of v of t dt. Or we can break the integral, sorry, I think something's off here. So if we want to do the distance, we're supposed to be using the absolute value, right? So, and I noticed that on the test, and I shouldn't say too much, but you got to watch your absolute value. Absolute value doesn't automatically become positive. It becomes plus and minus of 2 things, and then you have to go through your initial values to figure out. Yeah, so I was a little bit lenient on that, but honestly, you'll lose some marks on that if you don't actually show that it goes to 2, then you check. It's kind of like when we were in 40 pre-cal and we got 2 answers and you rejected one. You have to show both answers and show your rejection. Kind of same thing, right? You got to show that absolute value goes into 2 different things and then figure out which one actually works. So, or we can break the integral into pieces and subtract. Because if we subtract the negative or the area under the curve, then that really means I'm adding them together. So we're going to use a graphing calculator for the first example. So suppose the velocity of a particle moving along the x-axis is v of t equals 6t squared minus 18t plus 12 between 0 and 2. When is the particle moving to the right? When is it moving left? And when is it stopped? Okay, so let's get our graphing calculator out. Okay, so we need to put this into y1. So we are going to be putting 6t squared, well, in this case 6x squared, subtract 18x plus 12. Now if I go, here I'll go to large screen. If I go zoom 6, we're not going to see the best viewing window. We need to see between 0 and 2. Does everybody understand? Because it's going from 0 to 2. So if I go to window and I change my max min from x from 0 to 2, we can see it a lot better. Yeah? Okay, so I'll put this on here. And that's what it looks like. So this is how we're actually going to, does anybody remember how we know when, or what are we supposed to look for to find when the particle is moving to the right? Yeah, v of t is positive. So that would be, we need to figure out where that is. It is actually 1. Don't just assume that it's 1, but you should actually, how could I figure it out on my calculator just to make sure? Yeah, calc 0, right? That tells you, because that's an x-intercept, right? So my domain would be from 0 to 1. Does everybody see that? And where would it be moving left? That's where v of t is less than 0, so that would be from 1 to 2. And where has it stopped? Where do I look? Yeah, v of t equals 0, and that would be at 1 and 2. You could check to make sure, but it is 1 and 2. I'll say t equals that. Okay, so now we're going to find the particle's displacement. Displacement is what now? It's just the integral. Okay, so here's a way to save time on the exam. You already have this in your y1. Does everybody understand that? So there's no need to type it again. It's already in y1. So when you find the integral, use y1. I'll show you what I mean. So, and by the way, remember we can't show calculator keystrokes for what we write down. We have to show the actual, so we're going to go from 0 to 2. We do not have to write the whole entire equation. We can just write v of t dt. That is sufficient because in the question it tells you what v of t is. So this will save time by not writing it down. Okay, so now we're going to go, I know your calculator is a little bit different than mine, but we're going to go to the calculator and we're going to go to calc. Oh, what's going on here?
You say y1.
Yeah. Oh, try this again. We're going to go to 7. Oh, I guess I'm in there. Let me quit out of there. Well, I could have done it there. Anyways, but I was trying to show you to this way so then you don't even actually see it in there. So 7. Oh, it still does it that way. The lower limit is 0. The upper limit is 2. And do you see you get 4? Yes? Okay, I was trying to do it the other way. I'm going to show it the other way as well. I'm going to do it the other way without showing the graph. Yeah, that's why I wanted to show it to you. So if you go this way, I'm going to quit out of there. And I'm going to go to math. That's why I was doing it wrong. Function. I know yours is going to be a little bit different. So this is where usually we put the equation, right? So don't type the equation and type y1. How do you do that? You go to vars, y vars, function y1. So that's where I get the y1 from. You should be paying attention. And then you go x, comma, 0. Oh, yours is different than mine. I need to upgrade mine. Yours is the same. Okay, so what's the difference between displacement and distance? Yes. So what you can do is you can split this up. Okay, hold on. You can split this up, and you know wherever it's negative, you can subtract the negative part and split it up like that. Because you know from 0 to 1, it's above, and from 1 to 2, it's below. But I'm going to show you a little cool little thing. It's called the absolute values. It's in math. So you can do the absolute value of y1, and it'll give you the correct amount here. So go to math. And then, of course, we're doing the integral, which is 9. And now, before you type in y1, do the absolute value. So math, the absolute value is it? It's a num1. There you go. Num1. Remember, we go vars, y vars, function of y1. Close the bracket because otherwise it's going to think it's absolute value of everything. So close the bracket of the absolute value, and then of course I'm going to do x, comma, 0, comma 2. Bars, y bars. So then I get 6. Oops, I gotta switch to the next page, sorry. Ah!
So what was the 4 that we got there?
4 was distance. Sorry, 4 was displacement. 6 was distance. So just to repeat, right here, do you see this graph here? I'm just gonna put it over here. Copy it. Does everybody see there? Essentially what this is showing here is, in order for this to be 6, how would I get 6 as the whole thing here? So what do you think the area from 0 to 1 is? Yeah, there is. Yeah. So we can actually try. We're going to do that in a second without a calculator. We're going to split it up with the integral. Okay. We need to write it. We can't just put the answer of 6, and we can't put our calculator keystrokes. So this would be the absolute value. Sorry, the integral from 0 to 2 of the absolute value of v of t dt, and we would get 6. Okay, so you actually have to write it out. You can't just put 6 down. You got to put what you actually. No. No, you don't. If you want for your own notes, but for the exam, you don't have to have it. No. Okay, so now we're going to do it without a calculator. We're going to find the particle's total distance by breaking it up. So we already know ahead of time that it's positive area between 0 and 1 and negative area from 1 to 2. So how are we going to do this? Well, we don't have a calculator, so we don't really know it's from 0 to 1 and 1 to 2. So how would I figure that out if this was a non-calculator part? We already know the answer is 6, right? So yeah, solve the intercept. So how do we do that for a quadratic?
0 equals?
Yeah, 0 equals. So I'm just going to, I don't have from the previous page, v of t equals 6t squared minus 18t plus 12, right? Okay, so we would set it equal to 0 and solve, right? So 0 equals 6. You know what? You can totally, and instead of factoring it out, divide 6 out of there, right? Get rid of it. So 0 equals t squared minus 3t plus 2. So 0 equals t minus 2, t minus 1, which means I have 2 and 1. You should be dividing it out. Unless it's not an equation, right? Then you can't do that, right? Okay, so now I need to do a sign diagram, because remember, although I saw what the graph was, I don't really know, because I'm redoing the question without a calculator, so I'm pretending I never saw this graph. So, put the sign in for, well, you could put 0 if you want, right? Because 0 is on the left of 1. What do we get? Positive. Put 1.5 in here. We get negative. And honestly, we don't care about anything on the right of 2, do we?
No,
because it's going from 0 to 2. So actually, we don't need that part, right? Okay, so we know that the integral from 0 to 1 is going to be a positive area. We know from 1 to 2 is going to be negative. Does everybody understand how I figured that out? Okay, so now we're going to break it up. We're going to go from 0 to 1 of v of t dt. And then, because I know it's negative, I'm going to do what? Subtract the integral from 1 to 2 of v of t dt. Does that make sense to you why I'm subtracting? Because I'm going to get a negative area, right? So then minus minus means plus. So we'd have to integrate this, right? So what do we get? So add 1, divide, so we get 2t cubed, yes? Do you know what I'm doing here? Add 1, divide, we get minus 9t squared And then plus 12, and we're going from 0 to 1. Is everybody good with what I did? Oh, yes, sorry, 12t. Yep. Okay, and then we're going to subtract. And I might want to put bracket just because it'll get messy in a second here. So it's the exact same thing. So 2t cubed minus 9t squared plus 12t from, this time it's from 1 to 2. Yes? Okay, we're going to put this in. So 1 goes in and we get 2 minus 9 plus 12. And does everybody see we're going to subtract 0 in a second? So if you want, you can put subtract 0. Maybe I'll put brackets in this first one just to know this is this first one. Yes? Okay, then we're going to go subtract. Now 2 is going to go in. We're going to get a little bit of, remember there's no calculator. So 2 cubed is 8, 16. Yes? 2 squared is 4. 4 times 9 is minus 36. 2 goes in, we get plus 24. Now remember we're subtracting whatever 1 is, right? So how do you guys usually do that? Do you go subtract bracket or you just change all the signs? Okay. You do subtract brackets? Okay, I'm going to do subtract brackets. So 1 goes in, I get 2 minus 9 plus 12 in bracket, bracket. Okay, so I get 2 minus 9 is minus 7 plus 12 is 5. Everybody agree there? Okay, I'm going to go bracket. 16 minus 30. Did I ever show you the trick where I combine the positives then the minuses? It's faster. It really is. So 16 and 24 is 40. 40 subtract 36 is 4, right? And then subtract, and if I do it here, I get 14 minus 9, which is 5, yes? And then really this is 5 subtract negative 1, which is 5 plus 1, which is 6. So does everybody see? I get the same answer. I knew I was going to get 6. This is how you do it without a calculator. So way faster if you do it with a calculator. So here's the thing. On the exam, if this is on the calculator part and you know you can do it with a non-calculator, like without a calculator, don't be stubborn and do it without the calculator because that's the math way of doing it. It's like, no, you have to have speed here, right? So save time, let the calculator do the work. If you have time later, I guess you could check it by hand, but that's not what the intention is. The intention is to do this fast, right? So anyways, okay. Example 2. A particle travels along a horizontal s-axis from 0 to 5 with velocity ds dt equals t squared minus 8 over t plus 1 squared centimeters per second. Describe the motion. So this is a calculator question. So let's graph it. So let's look it up. Yeah, ds dt is velocity, right? Yeah, okay, just making sure everybody's up to speed there. Okay, so we are going to go to y1 and we're going to put this thing in there. I'm just going to clear it first maybe. X squared subtract 8 divided by bracket x plus 1 bracket squared. Looks good. So I'm going to go zoom 6. And then I'm going to change my window to what? 0, 5. Does everybody know I'm doing 0, 5? Okay. So, oh yeah. So we need to go maybe a little higher up, but maybe we don't care. Does anybody know, instead of guessing how high up it is, a way to actually figure it out? Go to your table. So if you go to table, do you see it's going, maybe we need to change what it's going up by because it looks like it's going up by goofiness here. But anyways, do you see at 5 we should be at about 25? So we need to change our window settings so I can see that. It's not, sorry, I should go back. When I'm going, because this is only from 0 to 5, from 0, this is essentially 0, and this is 5. So I need to go from, say, negative 8. So you could say negative 10 to 30 if you want for your window settings for Y. So I'm going from negative 10, which it was, to 30. I said 30, right? Yeah. Okay. So now I can see the whole entire graph window that I need to know. Now here's the other thing. Again, this is calculator. There's a significant thing happening right here. I need to know what that is, right? In order to describe what's happening, I need to know what happened here. So how do I calculate that again? Yeah. So go to calculate, and we've got to go to 0, and we're going to go on the left. Remember, you have to be on the left side of that 0. That's what left bound means. And then on the right of it, and then the guess who, I don't even know why they have it in there. Such a waste. Yeah, so I'm going to put that on here so we can talk about it here. Okay, so describing the motion. Can anybody, like, what is this negative, what does this mean right here? What does that mean? Like, where it's negative. Like, I just want you guys to analyze this before I actually give you the answer, what you should write. What does this mean right here? It's moving to the left. And then what happens right here? Well, it stopped. And then moving to the right. Does everybody understand that? That's what you're seeing? Because for some, especially the non-physics people, this is really like a stretch for some people, right? So if it is, you're just going to have to memorize when it's negative, it's going to the left. If it's positive, it's going to the right. Yeah. Yeah. Okay, the other thing is does anybody know what the start, like what did it start? Where's the starting velocity at? So I would have to either calculate that, or I can look on this really fast. Does everybody see 8? Yeah. So, okay, so here's the thing, and I'm pretty sure this is how it is in physics. You never say negative 8, you say 8 set to the left.
Or backwards.
Yes. Yeah, so we're going to do left and right in this course, okay? So that's how we're going to describe it, okay? So never use the negative, you're supposed to use the direction. Okay. I know, but that, yeah, I don't know if it...
Technically correct.
Yeah. So this is a particle. So describe the motion. The particle has an initial velocity of 8 centimeters per second to the left. Okay. Now we're going to say how long it continues to the left. Does anybody know? Yeah, right there. It tells me for 1.25 seconds. Okay, we're going to do 3 decimal places though. So it continues to the left until it stops. Until it stops at approximately 1.254 seconds. Okay, so then until it stops, approximately 1.25 seconds, and then after this, what happens? After this, it goes to the right with, now what's happening with my velocity here? Yeah, so with increasing velocity, and reaches, that would be acceptable, and reaches, what's my final velocity at 5 seconds? Reaches, okay, so what's the fast way of doing that? I'll get my calculator. Oh, you could do the table. That's what you did?
I feel like it's a little bit faster than the calculator.
As long as it's, yeah, like, so for some reason, yeah, you could go, that's where I was going with calc value, and you get x equals 5. So there we go. Does everybody see? So another person was saying they just looked in the table, and it's right there, right? But I did calc value. That gives you the x value. When x is 5, y is this, right? So I don't know where to put it here. I'll just put it on top. I'll put it over here. It doesn't matter. Okay, the gap is the 24.778. 24.778 centimeters per second. Okay. Suppose the initial position of the particle s of 0 is 9. What is the particle's position at 1 second? This is new now. So when we did this original rate, that was assuming that where it started was whatever this produced, which was the 8 seconds, right? So now what they're saying is the initial position is 9, and then this happens. So the way we end up doing this is at 1 second, this would be our initial position was 9. Then we have to add whatever the integral, which the integral of velocity is the distance, right? So the integral from 0 to 1, why is it 0 to 1? Because it's starting at 0 and it's ending at 1, of v of t dt. So we already have the formula in our y1, so it's very easy. This is a nice, super easy calculator response question where you just go 9 plus that integral. And so I'll let you do that. And then what do you think you're going to do here? Yeah, 9 plus the integral from 0 to 5 of v. And did I show you the little shortcut? If you already have this typed in, you can just go second enter and then change that. So in like 2 seconds, you should be able to get both of them really fast, right? So 5.333 centimeters, and this is 44 centimeters. Did everybody get that? Okay, next page. We're still continuing. This is like a response question on the exam is 9 marks, right? So it continues and continues and continues, right?
It really tries to gauge your knowledge of the whole thing.
Yeah, yeah. Okay, so now it says find the total distance traveled from 0 to 5. So how do we do this again?
Obviously, that's what I.
Yeah, so it's going to be the integral from 0 to 5 of the absolute value of v of t dd.
Or is it S of T? Oh, wait, no, it's for
Yes, over dt.
velocity.
Yeah, so if you put ds dt here, that would be wrong, right? We're trying to find the integral of, we're like s, the total distance of s, right? So I would just say put the integral. Don't put what the starting thing is what I'm saying. Okay, actually this is going to be approximate,
Oh, we should have done that for the 5.33, right?
probably. You won't lose mark. You don't worry, they won't take marks off. So what did you guys get?
Still doing it. 1 sec.
586. Well, if you chop off, I do 4. So if you round, it would be 7. So 5868, right? And that would be what units? cm. Not squared. Just cm.
We don't add 9. All right, because that's the initial.
Oh,
It's total distance traveled. So is that from the starting position or from the origin?
Oh, because it's starting at, yeah, from 0. You're right. Yeah. Yeah, no. It's 0 to 5.
So both should be at that 9 that we have?
No.
Oh, wait, yeah.
Because it started at 9, and then we're kind of starting the time from 0 to 5, and it's only traveling there, right? All right, acceleration. A car is moving with an initial velocity of 5 miles per hour, accelerates at a rate of a of t equals 2.4 t miles per hour per second for 8 seconds. How fast is the car going when the 8 seconds are up? How fast? So we want velocity.
You have to find
Yeah, the integral of acceleration. Yep. Yep. So v of 8 would be the integral from 0 to 8 of a of t dt. But the initial velocity is 5 though, so this is only going to be the change from 0 to 8, just so you know, right? So then our final answer, we're going to add 5 to it. So, well, you could. Maybe we want to do it this way then instead. You don't have to erase the whole thing. I just accidentally did. So 5 plus 0 to 8 of a of t dt. So for the velocity, I get 76.8. And then if I add 5 to it, maybe I should put it in the other order since 5 plus 76.8 equals 81.8 miles per hour. Yes? Okay, so now we need to figure out how far did the car travel during those 8 seconds? Yeah, and so we do have an initial value in disguise there too, right? So your calculator can only do so much. Yeah, you can. Yeah. So, but you have to figure out your calculator, unless you guys can figure out, I can't. What do you do with that initial value to plug it in? To get the C, because otherwise you're not getting a plus C. You know what I'm saying? So v of t is the integral of 2.4 t dt, which would be 1.2 t squared plus c. Now if I put the initial value in, remember the initial value is v of 0 equals 5, right? So at times 0, it's 5. So 5 equals 1.2 times 0 squared. You don't have to write all this, but c is 5. You can pretty much, by inspection, see that c is 5. So that means v of t is equal to 1.2 t squared plus 5. So now we're going to integrate again. Yes? So what is the integral of velocity? Distance. We're going to use d or s. You like s or? Yeah. Okay. Oh, sorry. How far? So, hold on a second. We got to watch here. Are we using? Is this distance or displacement? Because s of t would be displacement, right? D, I'm talking about is distance, right? How far?
But is it far? Like, far is just total distance?
So, distance is equal to the integral from 0 to 8 of the absolute value of 1, and you could write v of t because I already put what v of t is, but 1.2 t squared plus 5 dt. Now, what are we going to get there? Huh? What does that number represent, by the way? What did you get? Did you get 244.8?
No, that's not.
244.8, but what's the units, I guess what I'm saying? What are the units? Okay. Okay, so, okay, I'm glad you realized that. That's a lot of miles in 8 seconds. Okay, so here's what this number represents here. So the problem is do you see all of this started from miles per hour? So when I started doing all this, and then I put 0 to 8, that was seconds, right? So we gotta change. This is now miles per hour. This is we started from miles per hour, right? And then we need to change. We multiplied it by seconds here, right? So do you see how my units are all screwy? Does everybody see that? So I need to have it. So first off, my units cancel and I get miles, because that's what I want is miles.
Yes.
Okay. So miles per hour. I did the seconds that I put in for the integration. That was the multiply. So I need to now get rid of, and I'm running out of room, so I'm going to shove this over. Let's undo that. Try it again. I'm going to move this over. Oh. Try again. Why is it not letting me? I don't want to do. Anyways, I'm just gonna write it over here because I'm having problems. That's okay. 244.8 miles per hour, and then I have it multiplied by seconds, and now I got to change hours and seconds. So remember, I hope you did in science somewhere unit analysis where they all cancel, and what you are left with is miles on top. So we need to get rid of hours and seconds. So does anybody know how many seconds are in an hour? And if you don't, 3,600, yeah. So there's 3,600 seconds in 1 hour. So the way you're supposed to, 1 hour is 3,600 seconds. So do you see the hours cancel and the seconds cancel? And when I take 244.8 and divide by 3,600, I will get how many miles are left, which is approximately 0.068. So I'm glad that some people actually realize that the answer didn't make sense at first, right? Because that you do have to ask yourself, like, when I get a number, does that answer make sense? Like what's going on there? Okay, we good so far? We have one more. Oh my gosh. Speed. Okay. Woo. So we have a tide here. The tide removes sand from Palm Beach at a rate of, modeled by this function R. The pumping station adds sand to the beach at this rate. So does everybody know what's happening? Sand's going out, sand's coming in. And at some point, at time t0, the beach contained 2,500. So they're giving you an initial value. So how much sand will the tide remove from the beach during a 6-hour period? Okay. Very carefully, we have to read the question. Remove. How much sand will the tide remove? So which function? The first one we have to use. But we started at 2,500 and we are no, this is not, sorry, how much is it removing? It's just asking for the rate. So what are we doing here? Yeah. Okay, so this we're going to punch into our calculator. I would make y1 r of t and y2 s of t, just so we have it handy. All right. So this is 2 plus, make sure your mode is in radians, by the way. 2 plus 5 sine 4 pi t divided by 25. And like I said, at the same time, you might as well punch in y2, which is 15t divided by bracket 1 plus 3t. Okay, so I'm going to quit, and I'm going to get out of there, and I'm going to go math 9, and I'm going to go, whoops, I need vars, y vars, function y1, comma, x, comma, 0, comma, 6. Okay, did you get 31.8? Yes? So what does this represent? So if this is a rate and we're integrating this this rate and it's talking about cubic yards, so what would that mean? This would be 31.8159 cubic yards. So that's how much got removed, right? It says write an expression for y of t, the total number of cubic yards of sand on the beach at time t. So that means at any point in time. So y of t is going to be, does everybody see that this is how much is coming in and this is how much is getting removed? And we're starting at that. So can we get this? Y of t is going to be, we're starting at 2,500 and we're going from 0 time to some time t, I don't know at this point, so I'm going to call it just time t. And this is going to be s of t minus r of t dt. It's saying find the rate at which the total sand on the beach is changing at time 4. So now this is rate. This is the rate. So this is actually, yeah, s of 4 minus r of 4. Do you know how to do that on your calculator? I'll show you. Some people were confused by this on the test when it had y of 2, right? So this is just, I'm just going to clear this. This is vars function y1 of 4. Oh, sorry. It's actually y2, isn't it? Scratch that. Try again. Vars function of y2 of 4 subtract var's function y1 of 4. What does that mean when it's negative like that?
It means that the rate is going to be decreasing.
Well, we're losing more sand than we're gaining, right?
Right.
So minus 1.9087 cubic yards per. What does the time stand for? Hours. Okay, so now it says between 0 and 6. The next, yeah, okay. It says from 0 to 6, at what time is the amount of sand at a minimum? So, how do we figure this out?
The derivative of the total amount of sand.
The derivative of,
Yeah, plus 3 centimeters. And then we can find the
okay, so what are we gonna, so we have a calculator, so what do you want to do here? Well, we can make a new function, right, y3?
yeah. Make it what? Y2 minus y1.
Yes. Well, but y3 is actually y of t, right? So we kind of have it already made for us, right? Yes? Actually, you know what? I'm not going to put the 2,500 in it. I'm going to do it later, right?
Yeah.
Now, here's the thing, though. We need to know where we need. Did we actually graph this at all? We haven't graphed this. What's a significant thing when we're actually figuring this out? Like, we should actually graph this on our thing. So let's do that. So go to your y and make y3 y2 minus y1. Do you know what I'm saying? Subtract y1. Yes? Everybody good? Okay, so let's zoom. I have no idea what to zoom this in. Let's go zoom fit just to see what's going on here. So it doesn't even like that. Oh, there we go. I don't know if it, oh, I have my y1 and y2 turned on. Did you know that you can turn your y1 and y2 off so you don't see that? That's why it was confused. So if you go to y1 and unhighlight this, do you see what I'm saying? And then I'm going to go to my window, and I know I need to go as far as 6. So I'm going to change this to 6 and go graph now, because then we can actually see it better. Okay, so some things going on here, hey? This is a significant thing right here. We need to figure out what that is. Because this is, does everybody know what this is happening? So this is the rate of it getting removed and coming in, right? So at this point, there's more getting removed, right? Because it's negative. And then at this point, this is significant right here, right? So we need to figure out what that is. So, remember how we do that? Calculate the 0. I don't even know where I am here. Yep, I'm on the left. Now I'm going to go on the right. All right. So I'm going to put this on here. Okay, so we need to figure out when it's a minimum and when it's a maximum here. So y of 0 is what amount? Remember, this was our thing here. It was 2,500, right? And then now we need to figure out y of 5.1178 blah, blah, blah. Do you remember how to keep this number so it's an exact? Yeah. So you see, this is there. And so we need to go to quit out of there and go x. And there it is, right? And then we got to store it. Store it into A or something, just so we don't lose it if we do another x. You know what I'm saying? So I'm storing it into A for me. Okay? So now I need to figure out what it is at 5.118. So that's going to be the, does everybody see? It's going to be this function from 0 to 5.118 of this. Yes? Okay, so how are you going to do this? Go to my calculator. Okay, oops. And I'm going to go 2,500 plus the integral, which would be math 9 of y3. So that's var's function. Oh my gosh, this is lots of stuff going on here, hey? y3 comma x, oops, I forgot the x. X comma 0 comma A, alpha A. Oops. I know, alpha A. There we go. Bam. It's thinking. Holy. Okay. And then the last one I need is, I need to know how much it is at y of 6. So that means I'm going to go from from 0 to 6 here. So I'm going to do the same thing again. Remember, I go second enter is the fastest way. And I'm going to change this to 6. And then it's fast. I got all that, bada bing, bada boom. There you go. Okay. I'm going to put this down here. So this is approximately 2492.3694, and that's going to be yards and yards. And y of 6 is approximately 2493.27667. Okay, so remember, in order to find a minimum value, it can be at the endpoints, which we always forget, 0 and 6. That's the endpoints, 0 and 6. And then it also is where it goes from where we cross signs, right? So that's why I'm testing that. So then what is my minimum? It looks like right there, hey? Therefore, minimum is 2492.3694 yards. And this is using by EBT, right? Extreme value theorem. You got to mention the theorem you're using to do it. Yeah.